In this short demonstration of the Pretectum CMDM platform, we'll show you how you can create the best possible golden nominal in just a few quick and easy steps.
We'll start with an existing container for a dataset. Creating a container just takes a few mouse clicks. The container uses the schema model as the structure for building up a dataset. The platform supports fast data loading from databases, applications, and files. These capabilities allow you to populate datasets on demand or continuously, or through cross-tenant syndication. Within the Pretectum platform, data is organized hierarchically. Data is securely held in the tenant and compartmentalized under a business area domain. The top-level navigation ribbon provides you with a menu that allows you to rapidly transition to the appropriate organizing structure of the models. Models are self-defined in the platform under the Schema navigator. In the Pretectum platform, a schema serves as a data model for your customer data profiles and can have virtually any number of fields or attributes and any number of subordinate datasets. Here you can see that we have 3 datasets defined: a nominated golden record store and 2 transitional datasets, one that is empty and one that contains 11 records. Looking into the dataset that we just loaded, we can see that the data has a number of different characteristics. Some records are missing values, have mixed case, and have mangled data. Navigating to the home screen, you're presented with panels that show recent actions or provide insights into particular datasets. The golden nominal dataset reveals itself to have 3 attributes that contain errors. A more detailed data quality analysis shows a count of errors by attribute. Diving into the dataset itself is quick and easy from here. Depending on a given user's permissions, they have the ability to see further details about the dataset at the dataset record level, add comments, start annotative workflows, and editing data in real time. If the customer data profiles contain email addresses, phone numbers, or address data, integrations will check the validity of the data beyond merely examining formats and configurable data constraints from the schema definition. A handy navigation breadcrumb allows you to navigate to the parent schema model and on to other datasets. Looking into the DSA dataset, we can see similar records, but in a slightly different state. Some have validated addresses, some have properly and improperly formatted phone numbers and populated address data. Some records also have missing data. This dataset could be a feed from some upstream database, application, or from some file store. At this point, we'll add another dataset to the DSP container, since when we examined it earlier, that dataset container was empty. The idea here is that each of these datasets may contain an additional or missing piece of the whole customer data profile. This situation is pretty commonplace, where data that comes from e-commerce, accounting, service, support, and so on all have slightly different views of the customer, different levels of customer density, and sometimes even unique data attributes that can only be brought together in this unifying platform. With the DSP dataset loaded, now we can see that this dataset also has some data issues, but contains data that may serve to improve the overall quality of the golden nominal. Looking into the dataset itself, we can see that it doesn't contain address data at all, or at least doesn't contain addresses that we might correctly recognize as addresses. For customers with AI enabled, the AI Assistant allows a variety of actions at the dataset and data record level. The supporting Model Context Protocol, MCP, delivered with the Pretectum platform can be addressed via this easy-access natural language assistant or via the Pretectum APIs. We'll ask the system to describe the overarching schema for this dataset, as well as some of the general characteristics of the dataset as a whole. A follow-on question related to the relative quality of the dataset returns a narrative regarding the records and their overall state or suitability for use, relative to the schema rules already established. If the user has permission to edit the dataset, they can perform actions against the dataset. In this instance, since we see that some of the email addresses are all lowercase, some are proper or title case, and some all in capitals, we'll convert all the email addresses to all lowercase. We can do this by simply asking the assistant to do this. Again, a few mouse clicks later, and you as a user are able to update a collection of records without needing to export the data and transform it and reload it, and without needing to use any additional specialized tools. After performing this selective update with AI assistance, we'll also go ahead and edit the email address for a specific record since we notice that it's missing a full stop in the top-level domain. With the data now ready for matching, we'll navigate to the Duplicate Search panel. Here we have an existing search that simply needs to be refreshed. This example is very straightforward. It uses a deterministic exact match search, where the email address is common across records. With the search and match executed for finding duplicates, we can now examine the nominated clusters of records. Clusters based on email address, in this instance, can now be manipulated. With just a few clicks, a user is able to select a survivor or target record and determine the merge criteria that might want for blending records. Merge rules allow you flexibility at the individual field or attribute level. Options include allowing the survivor to win in all cases, nominating a particular value to be found across all the cluster, the longest string, the most common value, or the shortest string. For dates and numerical values, other options exist also. A handy preview gives you clarity on what the end result will look like ahead of running the actual merge. This enables you to adjust the rules in detail to arrive at the perfect combination of blended attributes and merged records. An authorized user can continue to refine the merge criteria iteratively until they are satisfied that the end result will meet their expectations. This process of iterative rule building all happens without having any immediate or direct impact on the underlying data. Once you're satisfied with all the merge adjustments, you can execute the deduplication run in bulk. The survivors are retained, and the redundant or superfluous records are discarded from the clusters. Re-examining the data quality assessment of the dataset, we can now see that the quality of the records has improved. Diving into the dataset at the record level, we can see that while we haven't managed to completely address all the issues, the overall quality of the records has improved. Most of the records now have phone numbers and addresses and have properly corrected email addresses and some missing values filled in from other datasets. The changes to the records and datasets are fully audited with details at the attribute level with user and timestamp details. This verbose logging of every change action performed on every record in the platform helps with your own internal control and management process scrutiny, and it also helps you with meeting your compliance obligations with respect to customer data management. Hopefully, this short demo has given you a sense of the power of customer master data management as served by the Pretectum CDM platform. To learn more about how customer MDM, consent management, and other aspects of the platform can fit into your existing data platform stack, please do visit www.pretectum.com.